This is AP Calculus AB, and this is just a little bit of an extension on section 6.3, talking about definite integrals and antiderivatives. And really what this is about is just focusing on the difference between finding the total area versus the integral value. And a lot of this is going to involve using the calculator. So I'm going to have my calculator up, but if you have a calculator handy, make sure you get that out because you might want to go through some of these steps on your calculator as I do them. So there's really just one problem that I want to look at here. And we have this function x squared minus 4x plus 2. And there's two things that we want to find. Notice A here, it says find the integral from 0 to 4 of f of x dx. B says find the total area between the x-axis and the curve on the interval 0 to 4. Well, to solve the integral, this is pretty straightforward. This is not difficult to do. So essentially what we're going to do is take our antiderivative, which would be x cubed over 3 minus 2x squared plus 2x. We're going to evaluate that from 0 to 4. And when we plug everything in, you're going to end up with 64 over 3 minus 32 plus 8. All of that minus 0. When you plug in 0, all of those terms become 0. And in the end, what you're going to get here is negative 8/3. Okay, so we could do that by hand. We could do it on the calculator. The main thing is the integral is giving us the net value when we look at the areas. And when I say the net value, I'm talking about areas above the x-axis being treated as positives, the areas below the x-axis being treated as negatives. So let's take a look at this function and just look at the graph. And we were taking the integral from 0 to 4. So if I were to calculate this integral, and I'm calculating the integral from 0 to 4, notice the areas that I have here. I have these pieces that are above the x-axis, and I have these pieces that are below, or this piece that's below the x-axis. So net result there is I do have a negative integral value. Now, that's pretty straightforward when we do that with an integral. But what the second part of the question says is it says to find the total area between the x-axis and the curve. Well, if I were to take the integral, that's not going to give me the total area. So what we have to do is treat this in a little bit different way if we want to get the total area. One thing we could do is we could break our integral into 3 pieces. We saw those 3 sections on our graph. Make sure we subtract the middle section so that we have minus a negative and it will add it. But there's an easier way to do it in a situation like this because this question really doesn't work out very nicely. But what we can do is we can force all of those areas to be positive if we make that function positive everywhere. And so what I'm going to do whenever I'm looking for a total area, I don't have to worry about where the function is positive or negative if I have a calculator because I can just take the absolute value of that function. So I'm just going to integrate the absolute value of f of x, and that's going to take all of those parts where the function might be negative, and it's going to flip them over the x-axis and make them positive. And what we're going to get as a result is going to be our total area. So on the calculator, how we can do that is actually pretty simple. Okay, so remember this region right here in the middle is the one that I'm worried about. Well, if I go back to my main screen, what I can do here is I can just hit math, and then I'm going to do 9 to integrate. Remember, we're going from 0 to 4. I'm going to integrate that y1 function, but I need to make sure that I'm taking the absolute value. So I hit alpha window. I'm going to do absolute value, and then I'm going to hit alpha trace, select y1. And now I'm doing the integral of the absolute value of the function. And you'll notice the result I get is not the same. It's not the negative 8/3. We get about 4.876 as a result. So, which makes sense because if I'm finding a total area, I should have a positive value. So for this problem then, I know this is approximately 4.876. Okay, so keep that in mind. When you see a problem that says find the integral using areas, if you're finding an integral, the area above the x-axis is positive, the area below the x-axis is negative. Now, even if it says find the integral using areas, it's still an integral value. But when a problem is referring strictly to finding total area, you have to treat every area as a positive value. We're no longer treating this as an integral. So that's why we're solving this integral with an absolute value of the function, because we want to add all of those individual sections of area together. And by taking the absolute value, that's what that does.